Just you in the grotto, nothing but your nights on. We keep all the lights on, same again tomorrow. We don't need no bottle, purple color lip gloss, room with the saguaro. Ain't nowhere I would rather be, right between your holidays. Coffee on the Flintstone, jewelry on the ottoman. Baby, let me in, for I get way too adamant about it.
Hi, here's a video on shortcuts to differentiation. Remember, to differentiate is to take a derivative. It's the act of taking a derivative, and a function that you can do the derivative of is differentiable. So in this video, we are specifically working on the most basic of the derivative rules. We're not doing the long process anymore. Like I said in the intro, this is the shortcut, and it's the most basic one. There are going to be many more derivative rules coming. This is the basic one, but there's different ways you can use it. So my goal in this video is to show you all the ways that you could use this one basic rule. Emphasize these basic derivative rules are going to replace what we've been doing in class the past couple days. All right, so we are not really going to do the formal limit method anymore unless I specifically ask. Now that we know the shortcut, we're just going to go ahead and do it the quicker way. There is a special note for the different types of notation and different ways you can write a derivative. The most common ways are the ones I'm highlighting in blue. This way isn't seen as much, but you still need to know it. So this tick mark here means prime, just to emphasize that again, that's y prime. If you have the prime with f instead, you say f prime of x. This here, well, both of these actually are Leibniz notation. Remember, Newton and Leibniz are the two mathematicians credited with creating calculus or discovering calculus. And this is how Leibniz wrote it, dy dx. You literally say dy dx. Or you could say the derivative of y with respect to x. And if you write it like this, you could say the derivative of f of x with respect to x. Now this whole business of with respect to x, all that means is the variable down here in the denominator, that's the variable you're doing the derivative with respect to, or the derivative of, and that's your independent variable. So like independence on the x-axis. So in this case, if there's an x in the bottom, that's what you're doing the derivative of. It's your independent variable. In AP Calculus, it's always going to be x. But let's say you do a class called multivariable calculus in college. That comes after Calc 1, 2, and 3. It won't always be x because there's many variables, multivariable calc. So anyway, just again as a reminder here, all 5 of these ways are what we're going to be doing in this video, and in fact what we are doing, finding a derivative. So a derivative is instantaneous rate of change, slope of the tangent line. It's the limit of the slopes of the secant lines, and it's also the velocity if you're on a graph and it's time versus distance. All right, we're ready to start. So if you have not copied this page down, pause the video now and do so, and we're going to do a table with all the different types of ways that you could use this shortcut rule. Now, in your notebook, set up a table. The table is going to have several different pieces of it. But an important thing to realize is we can only use the shortcut if the function is in the following form. So function needs to be f of x equals a times x to the b form. All that means is you have your x, your exponent, and a coefficient. There's no fractions, there's no radicals, there's nothing else going on. It's just literally one term, and this will make sense whenever we get to the more complicated ones, okay? So let's start with the most basic type that I could do here, and I'll be writing the actual answers in this column right here. So in this column is the different types. Here is the example, here's the rule, and here is the example actually done out. So let's think about if I have a function f of x equals 5 or f of x equals 2. That's just like y equals 5, y equals 2. Those are horizontal lines, looking something like this in red. A horizontal line has a slope of 0. Now I want you to imagine, what if I told you to draw a tangent line to this graph? A tangent line is the graph itself. So this is the only time that a tangent line would touch the curve more than one time, because the tangent line is the function itself. And the slope of the tangent line would also be 0. So the derivative, which is the slope of the tangent line, would be 0 in both cases. Now, what if I have the function just f of x equals x? So f of x equals x is this line, 45-degree angle here from the x-axis, slope of 1. Again, if I said, hey, draw a tangent line on this graph, the tangent line is the line itself. It's not possible to make it hit just once. This is the only case here. A tangent line to a line is the line itself. So then you want to think, okay, well, what's the slope of y equals x? And the slope is 1 everywhere. So that means the derivative, which is the slope of the tangent line, is 1. Let's get to examples that have a little bit more involved. How about instead of just x to the first power, I have x to the n power, where n is any number, like x cubed, x to the 10th, 1 over x to the 7th, and x to the 5.8. So here's a derivative rule that you guys actually discovered in class whenever we were doing the sticky note activity and you all got your special numbers and you found your instantaneous rates of change approximations and we connected them. The basic rule is whatever your exponent is, if I start with x to the n, I bring x to the n down front, so now it's here, and then I subtract 1 from whatever my exponent was, so now it's n minus 1. So this is actually really quick to apply in these simple cases. So here you just bring the 3 down front, subtract 1 from 3, you get 3x squared. Bring the 10 down front, subtract 1 from 10, you get a new exponent of 9. So the new exponent is always less than what it was, and more specifically, it is 1 less than what it was. Let's take a look at this one, which causes people trouble at first until they realize what to do. So here's what you don't want to do. You do not want to say, oh, let's apply the basic rule and do 1 over 7x to the 6th. This is bad. Don't even write it down. I don't want you remembering the bad thing. You can only do the rule if it's in ax to the b. And this is not in the form ax to the b right now because I have a quotient or a fraction. So let's force it to look like ax to the b. So I'm going to rewrite it. And the way I'm going to rewrite it is I can force this not to be a fraction, meaning I can force x to the 7th to come to the numerator, meaning the exponent would be negative. So this is how I'm going to rewrite. And you're always going to do this whenever you have a fraction or your x is in the denominator and you want to do the shortcut rule. So now it's in the form ax to the b because a is 1 in front and b is negative 7. So let's go ahead and apply the rule now. So I'm going to bring negative 7 down front right here. Then I'm going to subtract 1 from negative 7. Now, negative 7 minus 1 is negative 8. So you're used to going like from 3 to 2 and 10 to 9. You don't go from negative 7 to negative 6 because you have to subtract 1, so it's negative 8. You're going left on the number line. Okay, you can also do with decimals. They're numbers too. So you bring 5.8 down, subtract 1, get 4.8. Now let's try it if I have a radical. This is supposed to say the nth root of x. All right. So here are my examples, square root of x and 5th root of x. Again, these are not in the form ax to the b because we have this radical here. So luckily, we know how to rewrite this so that there's no radical. You have to remember a square root is the same as an exponent of 1/2. And a 5th root, whoa, that should not be f prime. And a 5th root is the same as 1/5. Basically, whatever your index is, it's 1 over that index. And here's your derivative rule. It's the same rule that we've been doing the whole time. You take your exponent, you bring it down front. So your exponent was 1 over n, you bring it down front here. And then you do 1 minus whatever your exponent was. So it's, again, the same rule. You just have to rewrite it as a fractional exponent. Okay, so let's do the derivative of x to the 1/2. If I apply my derivative rule here, what I'm going to do is bring the 1/2 down. I have 1/2 x to the, and then what is 1/2 minus 1? So I have 1/2 x to the negative 1/2. Now let's say you don't want to leave it as a negative exponent. This is 1/2. And then x to the negative 1/2 is x to the positive 1/2. And then you could even rewrite it like this. Go back to a radical. Okay, so let's try this example here. I'm going to move it down a little bit so I actually have some room. All right, so bring the 1/5 down, then x to the, okay, 1/5 minus 1. That's negative 4/5. So then you have 1 over 5 x to the positive 4/5, which you could write as 1 over 5 x. So the denominator is your index. 5th root of numerator is your exponent to the 4th. So just do this minus 1. Okay, let's do a couple more. Just 2 more here. If I have c times x to the n, this is the same exact thing we did with x to the n, except I have c copies of it because I'm multiplying by any constant c. So here are 2 examples for you. Thing to remember is you're still doing the same exact derivative rule you just read above. It's just you have this constant c, which is coming along for the ride. It's just hanging out there out front, waiting for you to multiply. So if I do the derivative of 4x to the 9th, and I do out all the steps, 4 is just coming along. The derivative of x to the 9th is 9 times x to the 9 minus 1, which is 8. And then you can just combine and get 36x to the 8th. If I do it with this example here, 3/5 is coming along for the ride. I bring my negative 2 down, so I have negative 2x to the negative 2 minus 1 is negative 3. So now let's clean this up a little bit. That is the same as negative 6/5 x to the negative 3rd. And let's say I don't want a negative exponent. That would be negative 6 over 5. Throw x to the negative 3 in the denominator and make the exponent positive. Okay, last one. Let's say I have a function, f of x, and the function is made up of other functions added or subtracted together. Not multiplied or divided, only added or subtracted. And it doesn't have to be just 2 of them. It could be 3 of them. In this case, I'm just going to do 2 things added together, but it can be many. For the derivative, all you're going to do is the derivative of the first plus or minus the derivative of the second. So it's same thing you've been doing, just over and over again until you get to the end. So let's do these here. If I want to do the derivative of 5 plus 3x to the 10th, well, the derivative of 5, okay, that's a constant. Derivative of a constant is 0, plus 3 comes along for the ride, 10x to the 9th. If you want to just go ahead and go right to 30x to the 9th and multiply in your head, that's the goal to get to that point. I'm just showing out all the steps right now. For the next one, square root of x. Okay, let's rewrite it as x to the 1/2. So the derivative is bring the 1/2 down. X to the 1/2 minus 1 is negative 1/2. Plus, let's do this in our head here. Bring the 3 down. 2 times 3 is 6. X to the, subtract 1, second. And you can write it as 1 over 2x to the 1/2. Plus 6x squared. And we're just going to leave it like that for now. Don't worry about combining anything or common denominators. And, make sure you put a tick mark here, f prime. Okay, so this one here, 4 over x to the 7th. Okay, I need to write it as ax to the b, so 4x to the negative 7th. Now I can do my derivative rule. 4 is coming along for the ride. Negative 7x to the negative 8 plus 11x to the 10th. Let's clean it up. Multiply our coefficients. 7 times 4 is 28. Throw x to the 8th in the denominator. I don't want negative exponents. Plus 11x to the 10th. All right, so we're going to practice this in class. Make sure you've done up through 10 on your half sheet. It looked like this, and I had a bunch of rows and boxes. You're just doing the first 2 rows. And I'll see you soon. Bye.